we have some postgraduate helpers here today, so they're going to come around and give you hints if you get stuck, or and see how you're getting on generally. You can work together, work on your own. Occasionally I will say something from the front again or ask for feedback. Right, so we'll start by me saying something about what's going on. And so far we've only really talked about what I call subsets of R, which means sets whose elements are real numbers, some or all of the real numbers, like the natural numbers, the integers, the rational numbers. Those are sets of real numbers, but the elements in them are real numbers, so they're subsets of the reals. Whereas if you go to something like the complex numbers, that's not a subset of the reals anymore. Okay. So if you've got two different subsets of real numbers, you can define the sum of those two sets in the following way. Now, this definition is unlikely to come back very often, though it is on the definitions, proofs, and examples sheet. And I bring this in as an example of a definition that you won't have seen before, and so that we can see how on the spot we can make some deductions about even using a definition that you've never seen before, we can still work with it. I remember a few years back I set a question about the sums of sets to second years. On the question sheet I gave the definition of the sum of two sets and I asked them some questions about them. They weren't particularly easy, but the response I got from the second years was, it wasn't fair to ask us questions about a definition that you gave us on the question sheet. And that bothered me because it should be reasonable to ask you questions about a definition I give you on a problem sheet. You shouldn't be afraid of them, and you should be able to do some work with them. And that's part of the reason for the definitions, proofs, and examples question sheet that I've handed out. And on the exam, you could be given a definition that you haven't seen before and asked to work with it. That's slightly more challenging than working with a definition you have seen before, and therefore it gets more credit. Okay? So it's more valuable to be able to do it, and you need to be able to do it. So here we are. The sum of two sets is basically everything you can get by adding something in the first set to something in the second set. So you have to find something in the first set, add it to something in the second set. That gets you one of the things in this set. Two ways of doing it. You can either write it as y plus z, where y is in A and z is in B, or equivalently, those real numbers x for which there exists a y in A and a z in B, so that y plus z equals x. These two definitions are actually the same, but you may find one of them easier to think about than the other, depending on which question we ask you about. So it's all possible real numbers you can get by adding something in A to something in B. It's not the union. Okay? It's very rarely equal to the union, though you can do it artificially. On the definitions, proof, and examples sheet, I give you there's questions like find examples where it is a union, find examples where it isn't the union, various things like that. But generally speaking, it's got no connection with the union. So, to see whether you can do something easy using the definition, here's a set A, here's a set B. Add the set A to the set B. How many elements are there in the resulting set using the definition? So that's your first question. I'll just give you a couple of minutes to think about that. See if you can work out what this set is. And yeah, the students, just in case there's any questions about this one, you can go round, and then just to make sure that people get the right idea, then I'll take a vote on it. Okay? So just give you 2 minutes on this one, because it's very easy. Okay, I think we can probably go for a vote. Let's see. Got 53 answers so far. If you want to vote, please vote. Got quite a lot of different answers so far. Okay, well, so we're up to 94 answers. Let's have a quick look. What have we got? So we've got big majority in favour of B, okay, but still quite a substantial number of people going for some of these others. So it could be that working with the definitions has not quite worked. Let's see what we've got. B4 is the correct answer. So you have to look at everything you can get by adding something in the first set to something in the second set. So that means you have to look at all the possibilities you can get, which is 1 plus 5, 2 plus 5, 3 plus 5, 1 plus 6, 2 plus 6, 3 plus 6. I'll write all those down just to do it really slowly. So 1 plus 5, 2 plus 5, 3 plus 5, 1 plus 6, 2 plus 6, 3 plus 6. But remember, we don't care about repeats. So if something turns up more than once, we only need to list it once. And that's got in 6, 7, 8. 7 again, but we don't care. 8 again, but we don't care, but we do get a new one with 9. And that's the set. When you add those two sets together, you get 6, 7, 8, and 9 as your set, which has got 4 elements. Right. OK, so that was your easy starter, but it's already caused a certain amount of disagreement. This one may cause some disagreement too, OK? So, question 2, and this time we won't come around and help. We won't come around and help you with this one. I'm just going to let you discuss it for a minute and vote again. A is going to be the set of all real numbers. B will be the empty set, so there's nothing in B at all. And you have to figure out from the definition, and you can use either version of my definition because one of them might be easier, what is the set A plus B this time? Don't vote yet because I got to 0 the answers. And your task is to figure out whether it's the whole of all the real numbers, or just the empty set, or just got 0, or something else. And try to convince your neighbour. We definitely split the class on this one. Right, let's see what we've gone for. We've got a majority in favour of A, we have a substantial minority in favour of B, and a few other answers scattered around. And this time, the majority has got it wrong. Okay? The correct answer is B. So let's see, why on earth should that be? Well, to be in the sum of two sets, you have to be able to find one element from each set that adds to give you. Let's just go back and look at that version of it. I'll just zoom up to one at the top, yes. It's those real numbers for which there exists a y in the first set and a z in the second set with y plus z equals x. But the second set is the empty set. So there doesn't exist a z in B. So this condition cannot be satisfied. It's impossible to find anything in the empty set which you can add to some other real number to get a real number. So the answer is there's nothing in the sum here. Okay? So take care when working with definitions. The empty set is always a bit of a problem. There are no elements of B available to add to anything. So you feel like you should be able to get all real numbers because you can already get all real numbers from the first set. But the fact that you can't find anything in the second set to add to them ruins everything. Okay? So, okay. Now we've got some idea about some of the two sets. Now, let's have a look at the following thing that will turn up at various points in this module, which is how do you show that two sets are equal? Two sets are equal if they've got the same elements. Remember, elements are in or they're not in. We don't care how often they're in. That doesn't make sense, right? So you have to check that anything that's in one set must be in the other and the other way round. Now, I'm working with subsets of the real numbers, so what you can do is you can say that for every real number, you need to check that if x is in the first set, it's in the second set, and if x is in the second set, that it's in the first set. This double-headed arrow means you need a two-way implication, and you need to get that x is in A if and only if, that's another way of saying the two-way implication, x is in B. And that's two different implications, and we often have to prove them separately, and sometimes one implication is harder to prove than the other. And that's going to be true for us in a minute. Okay? So, in a minute, we're going to try and prove two sets are equal. And it's going to be quite easy to show that if you're in the first set, then you must be in the second set. Or maybe it's the other way around. But you won't be able to, but the other way around is going to be harder. Now, don't try this question yet, because I'm going to say something about it before you should start it. And it's going to be chopped up into basically, I'm going to chop it up into 2 bits. And one bit's going to be easier than the other for you. And it's about sums of sets. Now, these sets, this is interval notation. I'll just remind you what these sets are. Well, not all of them, but 0, 3, for example. It's a set of real numbers such that 0 is less than to x is strictly less than 3. And the other two are similar. Okay? So these are the numbers greater equal to 0 and strictly less than 7, greater equal to 0 and strictly less than 10. And I'm asking you to prove that if you add this set to this set in the way I've defined in this workshop, that you'll get the set on the right-hand side. Now, what happens is you have to show, you need the definitions of these sets, yes, and the definition of the sums of 2 sets. And now you take a real number x, and you've got to prove that x is in the sum of these 2 sets, if and only if x is in the other set. And it's 2 different implications, and one is easier than the other. So we're going to do the easy one first, which is you're going to start by showing that if x is in the sum of these 2 sets, then x is in the big interval. So I'll call that question 3a. Suppose that x is in the sum of these 2 sets, prove that x is in the big interval. And that really is pretty easy, but we'll start by letting you think about that. If you get through that quickly, you can start thinking about question 3b, but I will be saying something about 3b before setting most of you going on it. So have a go at 3a first, which should be relatively easy. And then we'll move on to 3b afterwards and see how we get on. OK, and I will pause the recording. Right, since a lot of people are stuck on the same thing, which is how to start and how to get into some notation, so I'm going to get you started on this proof, because a lot of people are stuck on the same thing. OK? To say that x is in the sum of these 2 sets is to say that there must be some element of the first set and some element of the second set which add to x. So we're given that x is in the sum of these 2 sets. There are a in the first set and b in the second set with x equals a plus b. That's how you start. Your task is to now use the definition of that interval and that interval to prove that x is in the big interval. So you just need to write down some inequalities and add them together, and it's as simple as that, okay? But getting started seems to have been a sticking point for a lot of people, okay? So you're allowed to, the definition, you have to use the definition, and to use the definition means you know that if you're in the sum of 2 sets, that means that you are of the form a plus b, where a is in the first set and b is in the second set. And now you're allowed to use all the information you've got about a and b to prove something about x. And what you have to prove about x is that it satisfies the right inequalities to be in this interval. This is intended to be the easy way round, but nothing's easy when you haven't done it before. Okay? So I'll let you carry on with that, because I think that people have found this quite tricky so far. I'm going to take the easy way out and simply write a proof. Okay? I think everybody's struggling a bit with this because it's early days and you're not used to using notation and definitions yet and writing proofs. So I'll write you my version of this proof. It won't be the only correct version. Right, I'll use the fact that a is in this interval. That tells you that 0 is less than to a is strictly less than 3. That's the definition of that interval. And b is in the other interval. So 0 is less than to b is strictly less than 7. So I can write that down. You see, a lot of stuff in this module involves simply writing down what you know from the definition of the object you're talking about. So, x is equal to a plus b. I'll do the greater equal bit first. A is greater equal to 0 and b is greater equal to 0. So this is greater equal to 0 plus 0 equals 0. Using the fact that a is greater equal to 0 and b is greater equal to 0. And x equals a plus b is smaller than, well, a is less than 3 and b is less than 7. So that's less than 3 plus 7 equals 10. So we've got x is greater or equal to 0 and x is less than 10. So x is in this interval. And that does that bit. Okay? So what did I use? Let's just have a look at what I used. First, I used the definition of the sum of two sets. I said, if x is in the sum of these two sets, it means that it's equal to a plus b for some a in the first set and b in the second set. Then I used the fact that a was in the first set to tell me something about a, and the fact that b was in the second set to tell me something about b. And then I was very careful in combining my inequalities, because you must never combine two inequalities that are incompatible. If you know that a is, suppose you knew that a was less than 3 and b was greater than 7, you wouldn't know anything about a plus b. Okay? But if you know that a is less than 3 and b is less than 3, then you do know that a plus b is strictly less. If a is less than 3 and b is less than 7, then a plus b is less than 10. That's okay. A less than 3 and b greater than 7, and you've had it. You know nothing about a plus b at all. So make sure you're dealing with compatible inequalities when you're combining them. Right, okay. So the other implication is harder. You're going to suppose that x is in 0, 10. And remember, that means you should immediately write down what that means, which means that 0 is less than to x is strictly less than 10. So that's the first bit of this part is going to be, oh, that means that x is greater than 0 and x is strictly less than 10. Okay? That's great. You have to prove that x is in the sum of these two sets. That means you have to prove that there is something in the first set and another thing in the second set which add to give you x. What you mustn't do, because it's the wrong direction, is say, suppose it was equal to the sum of something in the first set with the sum of the second set. If it was, then we'd be okay because it would be between 0 and 10. But that's backwards logic, okay? So you're not allowed to do that. You're not allowed to say, if it's a sum, we're okay. We have to show, if we're in this big interval, then it is a sum of something in here. However, the thing you find, of course, the pair of things you find will probably depend on x. So you could actually, there are actually a couple of good functions of x you can use. There's one function of x which is guaranteed to put you in the first set, and another function of x that's guaranteed to put you in the second set. And those two functions, when added, actually do give x. So if you can find the right pair of functions, you'll be all right. Otherwise, there's some more complicated arguments as well. So one method means finding a formula in terms of x of some numbers y and z that are guaranteed to be in these intervals, starting from an x in this interval here. And which add to x. So let's see if anybody comes up with a method of doing that. Again, we'll come around and help you. I think this one's harder, and it may be that I'll have to give you some hints, but we'll see how you get on with it. Does someone have a direct question before we start? Okay. So let's see if you... Okay, I'm going to provide a hint. It's quite a big hint. What functions can you think of mapping one of these intervals to another interval? You think you've got it? Yeah, some people have done it, right? Some people have done it, but I want to give some other people a chance, and then I'm going to come around and look at in a minute. Okay. But I don't want to spoil it for everybody else yet. So you're going to try and find a nice function f from 0,10 to 0,3 and another nice function from 0,10 to 0,7, and you're going to try and design them so that when you add them what you get is x. If you can do that, you can then use it to solve this problem. Okay, let's see if people are able to do that. Okay, I'll write a proof now. More and more of you are getting it, so given x is in 0,10, excluding 10, we have 0 smaller or equal to x is smaller than 10, then it is undeniable that x is equal to 3/10 x plus 7/10 x. And why you would do that is because these are the obvious things to try to scale down the size of the interval to the size of the other two intervals. If you scale down this interval by a factor of 3/10, you'll get the interval from 0 up to 3. And if you scale it down by a factor of 7/10, you'll get the interval 0 up to 7. So this is a good way so that's equal to y plus z, where y equals 3/10 x and z equals 7/10 x. I said you're not allowed to start with y and z, but you are allowed to express y and z as functions of x, and if it works, you're okay. Now, they add correctly, but are they in the right place? So you need to check they're in the right place. Also, 0 smaller equal to x smaller than 10, so 0 smaller equal to 3/10 x is smaller than 3. You're allowed to multiply inequalities by positive numbers, and the inequalities stay the same. Multiplying by 0 always turns it into 0 equals 0, but multiplying by a strictly positive number, and the inequalities stay the same. And 0 less than or equal to 7/10 x is strictly less than 7. So, oops, where's the x? So that was y. Y is 3/10 x. So this is telling you that 0 is less than y is less than 3. And this one's telling you that z, 0 is less than z is less than 7. Not smaller equal to y is smaller than 3, and not smaller equal to z is smaller than 7, i.e. y is in 0,3 and z is in 0,7 as required. I've written more than you really need to write here, because I would have been satisfied, I think, if you'd written x equals 3/10 x plus 7/10 x and said obviously 3/10 x is in 0,3 and obviously 7/10 x is in 0,7, and that's obvious enough that I'd have accepted it. I've written extra detail in case anybody was worrying about it. Okay, so we're going to finish with one more vote. Let me delete the responses. And I'll just give you half a minute to think about this, and then we'll guess at the answer, but maybe you'll actually know the answer. For subsets of the real numbers, if a plus b is equal to a plus c, must b be equal to c? You can vote any time. I've cleared the voting. I've cleared the answers. Let's see what you're going for. Okay, we need to be finishing up. So let's first of all, if you haven't voted and you want to vote, please vote. Here we are, big majority in favour of A, which is the correct answer. So just, if we just have quiet for a moment, I just want to see if anybody's come up with an example to demonstrate this. Okay, yes, what have you got over there? Yeah, okay, so if we could just have quiet, please, for a second. The example from there on that side is if you took A to be the empty set, then B and C could be anything, and you'll still get A plus B equals A plus C equals the empty set. So they can be completely different if you take A to be the empty set. So that's correct. So e.g. if A equals the empty set, then A plus B equals A plus C equals the empty set, whatever B and C are. Okay, what I want you to do as an exercise for yourself, find examples that don't involve the empty set. But we'll stop there for now.